Long-term soil management at Camp Pendleton. Camp Pendleton is a major West Coast Marine Corps base established in 1942. The base covers roughly 125,000 acres in San Diego County, holding a wide array of soil types including large amounts of clay and sandy loam due to its unique geographic location located right near a beach while also being up in foothills. One of the largest Marine Corps bases in the United States is Camp Pendleton, which is bordered by residential areas including Oceanside and Fallbrook, and also bordered by the Cleveland National Forest. The area has a Mediterranean climate. Located in a bit of a real estate hotspot, Camp Pendleton is the only remaining undeveloped land area between San Diego and Los Angeles. It's home to over 1,000 species, including endangered plant and animal species. The ecosystems on this base include beaches, bluffs, mesas, canyons, mountains, and Southern California's only free-flowing river, the Santa Margarita River, which feeds into the Pacific Ocean. Other water features on this site include wetlands and streams. Camp Pendleton provides the groundwater for the drinking for all of the inhabitants on the entire base. And within the past 2 decades, they have been confronted by the EPA for polluted soils and groundwater. The Marine Corps went through and identified 9 sites containing soil and groundwater pollution. Since 1942, some of the operations on site at Camp Pendleton that have led to this pollution included vehicle maintenance and repair, landfill operations, waste disposal areas, pesticide use, scrap yards, and firefighting drill areas. Past disposal practices cause soil and groundwater pollution by allowing heavy metals and pesticides to leach into soils and eventually groundwater. These pollutants pose harm to plant and animal life, risk runoff into streams and eventually the Pacific Ocean, which further threatens marine life, as well as leaching into groundwater both at Camp Pendleton and surrounding areas. Some of the specific pollutants found in groundwater and soils on site at Camp Pendleton included VOCs, spent oils and fuels, PCBs, pesticides, metals, and herbicides. From 1996, when remediation began, to present, remediation efforts have mainly focused on soil and groundwater excavation, where polluted contents are removed, remediated, then disposed of in a landfill. These excavation techniques are both costly and unsustainable soil management practices. As of 2020, to date, over 51,000 cubic yards of soil have been removed from the polluted sites. Contaminated soils contain many different pesticides, some of which have been outlawed for use in the United States for decades. One specific pesticide, TCE, was removed via bioremediation, but all others were removed via excavation. The continued on-site vehicle repair and transportation of excavated soils via trucks still creates high methane output on-site. Soils are currently considered to be at safe levels of contamination, but these years of intense soil excavation practices has left little biodiversity and viability within the remaining soils. Heavy excavation has degraded topsoil, leaving unfertile and susceptible soil to erosion. Now that soil levels have been brought to safe levels of pollution at Camp Pendleton as well as groundwater, efforts need to switch from excavation to soil remediation and long-term management. As stated before, Camp Pendleton's unique location and lack of development means that it hosts vital plant and animal diversity for the area, including endangered native plant and animal species that have little other areas to inhabit. Abandoned contaminant waste sites can be restored to promote soil biodiversity and provide a habitat for these native animals and plants. Over 42,000 active personnel live on site at Camp Pendleton and daily produce human and food waste. This waste could be collected and composted on site to aid in the restoration and creation of a diverse and vital topsoil. The following slides entail a long-term soil remediation and management plan that I have laid out in order to further remove pollutants from the topsoils at Camp Pendleton while also establishing a vital and thriving soil life and healthy groundwater to provide an environment for local and native plant and animal species. Phytoremediation efforts using specific crops proven to remove metals and pesticide contaminants from soils will be grown for a period of at least 2 years on top of excavated sites. These crops are to be planted either via polyculture or crop rotation to remove any remaining DDT, DDD, and other harmful metals that still exist within the soil to reduce concentrations even further. While these plant roots grow to promote an environment for microorganisms which can replenish soil diversity and further break down remaining contaminants via root exudates. There's potential for gray water to be used from residents on site at Camp Pendleton in order to irrigate all of the crops while they're growing. While phytoremediation crops grow over time, they will be creating a more fertile soil environment while also removing contaminants from the soil. While these plant roots increase soil aeration and provide shade to the formation of new topsoil, food and human waste from Camp Pendleton inhabitants can be turned into beneficial organic matter to add to the soil fertility of remediated soils. A compost program must collect, deposit, and convert waste into compost over time. This funding could come from efforts or budgets that have already been put into very expensive and unsustainable excavation efforts. There's potential to establish 2 separate pile sites that can hold one with food waste and one with human waste piles, and empty sites, ensuring that they're a minimum of at least 500 feet away from waterways to avoid any further type of runoff into waterways. These piles will slowly be processed down into usable compost for beneficial plant growth via decomposition. The heat stored in these massive piles and generated during the decomposition process could potentially also be harvested or harnessed and used as an alternative energy source on site if desired. While the compost decomposes and after the allotted time of growth, the phytoremediation cover crops will be harvested and used as biofuels or could even be used to recover metals from specific sites. The soil will now hold less contaminants, more microbial life, and provide more pore space to hold nutrients and water for future vegetation growth due to cover crop root growth over the past few years. Quickly following the phytoremediation crop harvest, a thick layer of the on-site compost is to be distributed across the designated remediation areas. Over time, this compost will further decompose to replenish nutrients lost from the phyto-extraction harvests. In areas that have a bit of a slope to them closer toward the foothills, mulch, diversion, swales, and terracing as shown in the picture to the left could be implemented to avoid erosion before vegetation is grown in to hold the soil, but most sites are relatively flat. After the compost is laid, channeling inspiration from Masanobu Fukuoka, military drones will be used to disperse a mixture of native seeds over the freshly remediated area. These seeds will include native trees, plants, grasses, and flowers, including the endangered San Diego button celery. Again, this gray water setup could be used to provide initial irrigation needed to sprout seeds until roots are developed. With initial care and monitoring, vegetation will gradually grow into the remediated sites. The roots and organic matter will continue to provide a healthy environment for soil life, provide higher water retention, decreasing risk of further runoff and leaching into groundwater supply. Vegetation will prevent erosion as plants grow and evolve into a welcoming ecosystem for native wildlife. Considering they are native plants, eventually it is assumed that they will no longer need maintenance to continue to grow and survive in this climate. Carbon will be sequestered in the soil, emissions will be decreased on site through converting food waste and human waste into compost and decreasing trucks needed to haul away food and contaminated soil waste. This will decrease the amount of landfill deposits. Implementing this long-term soil management plan will transform a vital ecosystem in San Diego from this to this, a thriving land that will provide habitat for native plant and animals while also promoting biodiversity within Southern California. That is all. Thank you for your time.